Imagine a computer so advanced it could solve in 4 minutes what our best supercomputers today couldn't crack in thousands of years. That's not the future. That's what's being built right now. And the technology behind it, quantum computing, is shaping up to be one of the biggest leaps in human history. New medicines developed in years instead of decades. Climate problems we've never been able to model. Encryption that protects everything online, potentially crackable. Right now, the biggest tech companies and governments in the world are racing to build the most powerful quantum computer ever made. Because whoever gets there first holds a serious advantage in science, in AI, and in national security. But quantum computers work completely differently from anything we use today. So let's break it down. How they work, why they matter, and who's winning the race. Welcome to the Best Tech Zone. Let's tackle this together. This is going to be fun. Every computer you've ever used, your phone, your laptop, even the world's biggest supercomputers, works the same way at its core. Tiny electronic switches called transistors, billions of them, flipping on and off incredibly fast. On is a 1, off is a 0. That's it. Everything your computer does comes down to those two states. And for most things, that works great, but certain problems are on a completely different level. Simulating how molecules interact, cracking advanced encryption, modeling massive, complex systems like global climate patterns. These problems don't just get a little harder as they scale, they grow exponentially, and at a certain point, even the most powerful classical computers just hit a wall. That's when scientists said, we need to approach this completely differently. Quantum computers are built on quantum mechanics, the physics of the incredibly small, subatomic particles small, and at that scale, things don't behave the way you'd expect. In our everyday world, something is either here or there, on or off. But at the quantum level, particles can exist in multiple states at the same time. That's called superposition. There's also entanglement, where two particles become linked. Whatever happens to one instantly affects the other, no matter how far apart they are. Einstein himself called it spooky action at a distance. These aren't just interesting science facts. They're the actual mechanics that make quantum computers run. Are you still with me? Because it's getting interesting now. In a regular computer, information is stored in bits, either a 0 or a 1. In a quantum computer, you have qubits. And because of superposition, a qubit doesn't have to choose. It can be 0, 1, or both at the same time. Here's a simple way to think about it. Say you're trying to crack a combination lock. A normal computer tries every combination one by one until it finds the right one. A quantum computer can explore a huge number of combinations simultaneously, and the power scales fast. 10 qubits can represent over 1,000 states at once. 50 qubits can represent more states than most classical computers can process. Scale that up further, and you're in completely uncharted territory. That exponential growth is exactly why the world is paying attention. Now, one thing worth clarifying. Quantum computers aren't replacing your laptop. For everyday tasks, classical computers are still the better tool. But for specific, complex problems, quantum computers could be on a completely different level. Drug discovery by simulating molecules at an atomic level, quantum computers could dramatically speed up the development of new medicines and treatments. Artificial intelligence, quantum systems could process massive data sets faster, making AI smarter and more efficient. Climate modeling, running accurate simulations of complex climate systems, requires enormous processing power. Quantum computing could make those models far more precise. Encryption, and this is a big one. Certain quantum algorithms could break the encryption that secures most of today's internet. That's why governments around the world are watching this technology very closely. There is a legitimate global race happening right now. Check out my other video on AI chip wars that helps explain that in detail. I will leave the link in the description for you as well. Okay, let's keep going. IBM, Google, Microsoft, Intel, all of them are investing billions into quantum research, and governments are treating it as a national priority, not just a science project. The challenge they're all up against is that qubits are extraordinarily fragile. Tiny vibrations, heat, Even electromagnetic interference can disrupt a calculation entirely. To keep qubits stable, quantum computers have to operate in environments colder than outer space, near absolute zero. And these machines don't look like computers. They look like something off a sci-fi film set. Giant, gold-colored structures hanging inside ultra-cooled chambers. There's nothing else like them. In 2019, Google made a landmark announcement. Their quantum processor, called Sycamore, completed a specific calculation in about 200 seconds. The same calculation on a classical supercomputer, they estimated, would take around 10,000 years. That was the moment people started using the term quantum supremacy. When a quantum computer does something a classical machine realistically cannot. The calculation itself was very specific and not a practical everyday task. But the proof of concept was undeniable. It showed the world that quantum computing wasn't just theory anymore, and it pushed every major player to accelerate their programs too. With all that said, there are real obstacles that haven't been solved yet. The biggest is something called decoherence. Qubits are so sensitive they can lose their quantum state before a calculation is even finished. That causes errors. And in quantum computing, errors compound quickly. The solution is quantum error correction, but doing it properly requires an enormous number of physical qubits working together just to produce one reliable, stable result. We're talking potentially thousands or millions of qubits to support large-scale computation. Today's quantum computers are still relatively small compared to what's needed. Fully fault-tolerant systems are still a few years away, but progress is moving faster than most people anticipated. Every year, the numbers improve. If quantum computing reaches its full potential, the impact could touch almost every major field: energy storage, pharmaceutical development, financial modeling, material science, climate solutions. These are areas where quantum computing could deliver breakthroughs we simply can't achieve today. And there's the security side too. If quantum computers can break today's encryption, and experts believe eventually they can, the entire foundation of digital security needs to evolve. Researchers are already developing quantum-safe encryption to get ahead of that shift. The transition won't happen overnight, but the groundwork is being laid right now. Quantum computing used to sound like something decades away. It's not anymore. We're past the point of asking whether it's possible. The question now is how fast it's going to get here, and what happens when it does. The machines being built today could reshape medicine, security, climate science, and technology in ways that are hard to fully imagine. The race is already underway, and the finish line is getting closer. If you want to stay ahead of the technologies that are actually going to change the world, hit subscribe. We break it all down right here on the Best Tech Zone. Thanks for watching.